No fanfare from Coffs Harbour in Australia. Big shout out. So it's Fake Flip here again to tell you a little bit more about the tides. Tides is a very extensive subject, a very long subject, something that demands a lot of research, and certainly just one video like the previous video I made is not going to be enough. So I'm recording a little bit longer, a little bit more for you, a little bit more information. Today I'm going to be talking to you about the salinity, about the salt mines, about the amphidromic points, and all the things related to the subject of tides. In the ocean there are lots of salt mines, just as there are many salt mines on top of the continents as well, above the sea level. There are plenty of salt mines. And where are they located? Salt mines are usually located in deserts and in the vicinity of deserts. That's most likely because during the flood, the big flood that we had a few millennia ago, when the fountains of the deep, they burst and sprung all that water onto the surface, together also with the water that came from outside the firmament. The waters above also flooded earth during the flood, so the salt was released onto the surface and spread over the land, creating the deserts. So if you observe the deserts of earth, all of them, the deserts of the west of America, South and North America, there are deserts with lots of salt lakes, salt mines, salt plains, salt deserts, whatever you call them. I call them salt mines. And basically they are nothing but deposits of salt. It also happened in Africa, in Australia, in parts of Asia. Strangely, it didn't happen in Europe, and that explains why the Baltic Sea has no salt. The Baltic Sea has very low salinity, and as opposed to the salinity of the Mediterranean, Red Sea and other seas, the phenomena that we observe in the salinity of the Baltic is the opposite. So whereas in the Mediterranean we have a higher salinity to the internal parts of the Mediterranean, far from the strait is higher than near the strait, it means that the salt mines are located inside the Mediterranean. Now in the Red Sea it's the same thing. The salinity is higher to the inside of the Red Sea, and then it's lower near the strait. It's the opposite in the Baltic. The Baltic, we observe that the salinity is higher close to the strait. So it's a higher salinity near the straits in Denmark, and lower to the inside, so gradually lower to the inside. So it means that underneath the Baltic Sea there are no salt mines. So all the salt from the Baltic Sea comes from the Atlantic Ocean through the North Sea in that region. So this is the truth about salt. The salt was spread on Earth during the Great Flood. So most likely the whole ocean of Earth was a freshwater ocean. And the biggest evidence for this is the surroundings of the ocean. Antarctica is our great surroundings. It's our confinement. So the confinement is freshwater. If you observe the ice of the confinement is entirely fresh. We can even drink from that ice, even today. So if that ice is freshwater today, but the ocean is salty, it means that the ocean became salty after that. First it was made fresh and then it turned salty. So that's how the salinity happens. It was spread over the continents, and it was also spread over the ocean floor. The ocean floor and the seas in general, they have salt mines, salt plains, salt flats, call them whatever you want to call. There are plenty of them. Some of them are known already after the invention of submarines. They've discovered some salt plains, salt mines, salt lakes. Our scientists call them brine pools. They're called brine pools. Basically, they're nothing but deposits of salt on the ocean floor, on the seabed. So that's where they are, and that's why the ocean becomes salty. So without the injection of fresh water, what do you think would happen? It's very obvious. For those who have the logics in place, it's obvious that the ocean would become just as salty as a hypersaline ocean or sea or a lake, just like the Dead Sea, the Great Salt Lake in the United States, the Garibogoscal in Asia, or the Rakba in Senegal. It would become just too salty. and all the life would be extinguished from the ocean, and consequently we would die as well. So the importance of tides is notorious. The importance of tides is very visible in the question of salinity, and speaking about tides without speaking about salinity is nonsense when one explains the other and one justifies the other. So they are intrinsical, and it's impossible to speak about tides without speaking about salt. So having said that, it's also very important to know, for those who still wonder whether or not the springs may cause the tides or not, the springs is the only explanation to tides. It's a law of nature, has no exceptions, and all bodies of water that show tides, that have tides, all the bodies of water, they mandatorily, they must contain springs underneath and also holes underneath. So the holes are the amphidromic points, and it happens also in lakes. Lakes also have tides. I showed in the previous video. If you haven't watched, I recommend you scroll down in No Fanfare's channel and watch the video where I explain the tides. So lakes also have tides, and there are many types of different lakes, and the most interesting ones are the seasonal lakes called turlocks. So here in Europe there are plenty. Actually, there are turlocks. This is something that many people haven't heard about. Perhaps you have never heard about turlocks in your life. But turlocks are seasonal lakes, and they spend the summers empty and the winters full. So when it's springtime, about spring, they begin to drain. They begin to drain, and they spend then the summer dry. And then when it's autumn, they begin to fill up, and they spend the winters full. So this is what happens in turlocks. And the turlocks, they have an yearly tide, but some turlocks, like the Caherglason here in Ireland, it's a well-known turlock for daily tides. This one has daily tides, and it's a small lake, a small loch, as they say, like nearly a pond, but it has daily tides. So it's very important to understand that the explanation of tides in the turlocks is exactly springs underneath and also holes in the bottom. These holes, they are called swallow holes, which drag and drain the water, or they can be holes that inject water sometimes, like springs, but they also become a drain hole. So these holes that inject water and also suck water through the same hole, they're called estavels, and the other ones are called springs. So the tides in turlocks, which exist, they exist in all the north of Earth. To the north of the inside the circle of the Cancer, which is the like Earth is a circle, right? So the smallest circle inside is the Cancer. So the Cancer circle, it represents the north of Earth. So whatever is inside the Cancer is the north, and in that area, not just in Ireland, the word turlock is an Irish word which means dry lake. It means dry lake, but actually turlocks don't only exist in Ireland. Actually, one of the most interesting turlocks is in the United States, and it's called the Lost Lake. So the Lost Lake is a very interesting one because we can see the hole when it's draining. It happens every spring. Whoever lives in the United States or in the areas of the Lost Lake can see it in the spring. Many people have seen it. It's spectacular to see the water being drained down the hole inside that lake, and it happens in any other turlock. They all have a spring and a hole. In the north of Earth, lots of turlocks, and they spend the summers dry and the winters full. So it's an yearly tide that the turlocks have. So the explanation to tides in turlocks is springs and holes, and it's the same explanation for the tides in seas and also in the ocean, because there is no other explanation to tides. It's a law of nature, and it has no exceptions. So what explains tides in one place also explains tides in the other place. We cannot have two reasons for the formation of tides. If you have a tide in a lake, if you have a tide in a sea, or if you don't have a tide in a sea, which is the case of the western part of the Mediterranean, Marmara, Black Sea, also the whole of the Baltic Sea has no tides. So the explanation is the presence or the absence of springs and holes. Obviously, there must be a hole, because the amount of water that is injected is just too much. It would certainly flood Earth very quickly. Very quickly, we would be underwater. Given the amount of water injected, not just by freshwater springs, but also by the freshwater springs that are on the continents. The continents also they're filled with freshwater springs, which make our rivers. So all the rivers are formed by spring. In case you've never wondered about, in case you've never thought about, but 100% of the water available, including the water that is in our bodies, they're 70% water. 100% of the water available, including the water of the rain, the water that comes out from our taps, all the water available on Earth, including the ones making the rivers, the lakes, the seas, and the oceans, all of them, all of this water comes from inside Earth through springs, and they're all freshwater springs. Very few of them are not freshwater, will contain some sort of a gas, sulfite, whatever minerals that they might contain. Some of these very strong springs that we have in depths of the ocean, they're so strong they come out with minerals, but these minerals, they are not dissolved in water. They end up precipitating to the bottom, and the water comes out, and it's fresh water, and it has no salt, so it's less dense. It goes to the surface and sometimes even changes the texture of the surface, as I showed on the previous video. So having said that, the tides, they are very important for our lives. Without the tides, our life on Earth would be extinguished very quickly. The ocean, seas, and lakes, the lakes that have salt, the salty lakes, they would become too salty, and many of them are too salty and have no life inside, like Dead Sea, for example, has no life. It's not the case of the Caspian, though. Salinity in the Caspian is quite low, because the salt mine in the Caspian is not located underneath the Caspian. The salt mine of the Caspian is located to the side of the Caspian and is called Garabogaskol, which is a huge salt plain covered by the water of the Caspian. So basically, the Caspian has small tides of about 80 centimeters to 1 meter. So the water of the tides that are created inside the Caspian are enough for the Caspian to penetrate inside the Garabogaskol. That water then becomes salty, and at low tide the water exits the Garabogaskol through there's a strait, a narrow passage in the lake there. It's a kind of a lagoon. So that's why the Caspian becomes salty. It's not what the pseudoscientists say. They lie about everything on Earth. They know very well. They know I'm not the only person on Earth who knows this. They know very well what makes the Caspian salty, what makes the ocean salty. They know that there are salt plains, salt flats, salt mines, but they insist in indoctrinating the people that first, that the Earth is a ball, that the Earth is spinning, and also that the rivers bring salt to the Caspian, or that the Caspian once separated from the Mediterranean. It's another theory that they teach and that they preach. It's like preaching, that they preach in universities, that once the Caspian was part of a bigger ocean called Parenthesis, and that the Parenthesis divided, the waters divided, and then there was land in between both, and then the Caspian was separated from the Mediterranean, and that's why the Caspian is salty. This is one of these ridiculous theories that they teach and they preach in schools and universities, because they refuse to tell the truth. Obviously, they refuse to tell the truth because the truth sets us free. The truth brings us closer to God. The truth brings light to the people, and that's not what they want. They want ignorant people. They want people who don't know anything and still think they are smart. So that's the reason why very few people know these things. I hope that this information has been helpful. I hope that you leave your like to no fanfare, and whatever questions you put in the comment section that are relevant, whatever questions that are interesting and truthful, people who want to know information about the topics of salinity, tides, and turlocks, amphidromic points, whatever you want to know, be sure that I'll be glad to answer. Thank you very much, and see you around.